We are Group 4 of Alternative Energy Resources. My name is Shruti Koda. I will be presenting with Chris and Devin on the hydrogen economy and a specific SWOT analysis.
So just an overview of what our group will be covering today. We'll do a quick introduction to the hydrogen economy as an alternative energy resource. And then we'll look into the specific site that we have chosen to do on, which is the Asian Renewable Energy Hub project based in Australia. We'll then do a comprehensive SWOT analysis on the site itself and then give our concluding remarks based on what we have analyzed. So what exactly is a hydrogen economy? As we know, hydrogen is the most abundant element on Earth, but under normal circumstances, it is usually neither found as hydrogen H or hydrogen gas that can be used as a form of energy. So the concept of a hydrogen economy dates way back to 1972. So it has always been a field of interest. But as the global energy markets transition away from fossil fuels, we start to see hydrogen as a fuel that emerges as a potential resource that can take over fossil fuels. So it also enjoys extensive attention for a great reason, because like batteries, it is mostly used as a form of energy storage. And they both also depend on primary energy sources like solar and wind to charge or generate electricity when needed. So there are three main types of hydrogen colors: green, blue, and gray. And for our presentation specifically, we'll focus on green hydrogen.
So let us understand the production of green hydrogen. So a device known as the electrolyzer splits the compound, that is water, into its constituent elements using electric current. So we get hydrogen and oxygen. And if the electricity comes from a renewable energy source like the wind and the solar, the subsequent hydrogen is known as the green hydrogen. Once the green hydrogen is extracted, it is transported in its gaseous phase via pipelines or tube trail trucks, that is. Thank you. Next slide. So now let us look at the hydrogen production site of which we have done a SWOT analysis. It is the Asian Renewable Energy Hub, which is proposed to be the largest power station of Earth and is set to provide clean energy from wind and solar cheaper than fossil fuels. It is spread across 6,500 square kilometers in Australia, Pilbara region, and it will generate 2,600 megawatts of renewable energy from rich natural resources of the coastal desert side of Australia. The low cost clean renewable energy will not only be used to power the local mines and industry, but also it will give a way towards a large scale production of green hydrogen. Next slide, please.
So one of the most touted strengths of hydrogen, especially green hydrogen, is that it is a clean burning fuel. However, specific to the Asian Renewable Energy Hub, a very important strength is that the site plans to transport hydrogen using liquid ammonia as a carrier. So this is cheaper and easier than high pressure hydrogen in pipelines or even a cryogenic method, since the infrastructure already exists to transport liquid ammonia and doesn't require dedicated additional infrastructure to be built. The ammonia can then be converted into hydrogen at the desired location using an electrochemical fuel cell. So is it financially viable? As we can see in the chart, the hub predicts that post-2030, green hydrogen can be exported at less than $1.5 per kilogram and green ammonia under $350 per ton. This is substantially lower than the current market cost of green hydrogen, which can vary anywhere between $2.5 to $6.8 per kilogram, and green ammonia, which is currently predicted to be greater than $650 per ton. It's also important to compare green hydrogen to the cost of blue hydrogen, which is actually a bigger competitor for green hydrogen than fossil fuels, just because it is, it's lower carbon emissions, but also it's just cheap to manufacture versus green hydrogen. So you can see that the cost of blue hydrogen now is between $1.4 to $2.4 per kilogram. And so green hydrogen post 2030, according to the hub, will be comparable to blue hydrogen. So overall, this lower cost is primarily because the hub is powered directly by the renewable solar and wind power without any additional power from the Australian electric grid. Additionally, these costs will only decrease further as costs of both photovoltaic panels and electrolyzers reduce, and overall, it has a very promising financial outlook. Next slide, please. So some of the other strengths is that the hub is proposed on land belonging to the Nyan Gamarda people, and they have been in active cross-collaboration with the project since its inception. The Nyan Gamarda people have been actively working with the companies in participating in site ecological studies to ensure that the land is properly protected during the construction of the hub. And this is also important for all future green hydrogen products that are constructed in open lands, because it sets a precedent for working with the people native to that region to ensure that there's no damage done to the land in the construction of these hubs. Additionally, green hydrogen has the potential to be a major export revenue for the Australian economy, as Australia plans to be a top 3 hydrogen exporter on a global scale by 2050. So when looking at weaknesses, it's a pretty steep hill to climb when looking at the energy release per liter of fuel. It's true that liquid ammonia, according to the chart, may not produce as much energy as the traditional hydrocarbons. And even while it is better than hydrogen, it's true that it's important to factor in the push to move away from traditional fossil fuel forms of energy. So the momentum is here to make the shift, and it's important to factor in energy policy when looking at the financial viability of these alternative energy resources. When making these decisions, we have to weigh in the full life cycle of each product we consume, including the energy, starting with the extraction, manufacture, usage benefit, waste emissions, recycling and decomposition. And in order to get a complete picture, we also have to include the political factor of energy independence when looking at the weaknesses. Next slide. So other weaknesses are that the green hydrogen relies on wind and solar technology to stay alive, especially for the Asian Renewable Energy Hub. The cost of photovoltaic panels, turbines, and electrolyzers are all key for the green hydrogen to be a financially viable option for the future. Additionally, because hydrogen has a lower auto ignition temperature than the traditional fossil fuels, technical codes and safety standards need to be stringently developed in order to ensure that a very safe operations are being carried out and that there are no catastrophic incidents leading to injuries or loss of life within the facility.
Moving on to the opportunities. Firstly, to quote Federal Minister for Energy and Emissions Reduction, Angus Taylor, she states that this project has the potential to help lower global emissions while building a new Australian industry that creates jobs and opportunities in regional Australia. So the scale of this project will enable the creation of new supply chain facilities for the manufacturing assembly of equipment for wind and solar generation, as well as for hydrogen production. This will then create new local high-value jobs of approximately 20,000 jobs and during this 10-year project construction period, with 3,000 more jobs being created for the next 50 years during its operations. Another opportunity that we identified is that the Asian Renewable Energy Hub project will also help to encourage and contribute further projects being taken on a large scale throughout the world. So the Australian government has already committed more than 570 million Australian dollars towards supporting the development of a domestic hydrogen industry. And at present, they aim to focus on developing large multi-megawatt electrolyzers. To quote Janice Lin of the Green Hydrogen Coalition based in the US, she states that green hydrogen holds the promise of making the clean energy transition affordable, reliable, and scalable. So we can see that this is a sentiment that is being echoed throughout the world. And on this slide itself, you can see multiple headlines of different countries and nations starting their own green hydrogen projects. And moving on this slide, you can see the graphic of a variety of use cases by green hydrogen. So the exported energy from the Asian Renewable Energy Hub can be used across several industries, inclusive of transport, which includes EV, aviation, heavy duty, trains and shipping, the refining industry, power systems, and residential and commercial buildings. So one of the major applications for hydrogen, which is transport as mentioned, so far that lacks clear solutions for an ecological future, and it is still very early stage for us to meet the ambitious climate goals. So there will be a lot of research and development that has to be done in order for us to fill those gaps. But this also hints that there is great potential and versatility in the exported energy that can be used from the hub. And this is why it will greatly benefit the surrounding nations around Australia for their energy needs through this energy hub. And one last opportunity that we have identified that was earlier brought up as a weakness was that we also believe that hydrogen economy can be complementary to other alternative energy resources. So hydrogen can enable better integration of low carbon electric power resources. It could provide a significant source of flexibility for renewables like solar and wind, as you can see on the diagram, as well as even lithium-ion batteries. So this provides a long duration storage solutions that will complement the short duration battery solutions. So I think it's interesting to definitely consider the potential that they have in powering other renewable sources as well.
So let us discuss the threats concerning the Asian Renewable Energy Hub. So as the renewable energy sources already need to decarbonize the existing electricity demand, it can be possible that the hub would not match the capacities in various sectors. For example, in the LNG market, the LNG from the hub would only comprise of 1 or 2% of the global LNG market. The hydrogen produced at the hub will only be 40% of the gray hydrogen generated in Japan. Looking in the maritime field, it would only fuel 200 of the large containers among the 10,000 others running on ammonia. In the field of transportation, it would fuel 1 million long-haul heavy-duty trucks, which is less than one-sixth of just the European market. Next slide, please. So as we saw that in the current scenario, the blue hydrogen is cheaper than the green one. So when we promote hydrogen economy, we want to promote green hydrogen, and we fear that the energy producers might prefer the other colors of hydrogen as they can be more profitable for business. Uh, on in July 2019, a coalition party won the elections in Australia against the Labour Party, and the coalition party have a more economic standing in comparison to the ambitious mitigation targets of the Labour Party. This can pose a threat to the Asian renewable energy hub in the future. Next slide.
So when looking at the overall matrix, here's a quick comparison of all of the strengths, weaknesses, opportunities, and threats. Overall, the strengths are that the fuel is cheaper, cleaner, it uses ammonia as a transport mechanism, and it works with indigenous people in the area to ensure that the site is preserved. Opportunities are, given that the project has been given major status by the Australian government, it bodes promising future for the hub and other similar projects. The energy can be used across a variety of industries, and its momentum for countries like Japan, Korea, Indonesia to build similar facilities. Some weaknesses are that the liquid ammonia does release less energy per liter versus the traditional fossil fuels. It relies on wind and solar tech, which could potentially be bottlenecks. And there's a lack of guidelines and operating procedures in terms of dealing with hydrogen as a fuel. And threats are the lack of unified climate policy by the Australian government. The Asian Renewable Energy Hub by itself may not be enough. And so the country may switch to a more energy dense form such as nuclear, and other hydrogen colors may be preferred by energy providers.
So overall, just to give our concluding remarks and our own assessment, we believe that the transition into hydrogen economy cannot just be endlessly dependent on policy and subsidies. To use the analogy of the popular food innovation Impossible Burger, it wasn't a success because politicians imposed a tax on beef, but because it offered an environmentally superior substitute product which matches conventional meat burgers. Similarly, bringing that analogy onto energy resources, hydrogen-based clean fuels will be able to displace fossil fuels on the scale required only when they offer an equivalent zero carbon energy service at a comparable or lower price than oil and gas do today. Hence, we do believe that hydrogen economy, based on our discussions, can be a promising and emerging resource within the AER mix, especially with evidence of the cost of hydrogen production dropping at a dramatic rate in the short term. Also, with the climate change issue at large presently, we believe that there should be greater motivation to transition into green hydrogen in the long term, and that this angle will be worth advocating for and will garner the social support that it needs once other underlying concerns surrounding cost and safety are addressed. So just to end off with one last graphic that was taken from an opinion piece on Bloomberg. This is a map that shows countries throughout the world, companies and federal governments venturing into large-scale green hydrogen projects, just to reiterate what I've mentioned before, with solar and wind serving as blueprints to support them currently. We will also expect more standalone projects to emerge as the research and development on hydrogen economy resources catch up. And with that, that comes to the end of our presentation. Thank you all so much for your attention.